Hello. So this is quite a fun day for me because we get to launch a product and a company today, which is obviously quite a privilege to do. And it's actually the result of a few different products I've had the privilege of working on. So I thought I might go through that briefly just to give you a bit of context of where I've come from and where the company we're announcing today has come from. So I spent a lot of time working at Arm. And one of the first really exciting projects I got to work on was Neon, which was the V7 SIMD architecture. So I was tech lead for this project, and this was at a time where people were trying to work out whether people were going to watch video on phones, whether they're going to use it as audio players and things like that. So a really amazing project. This first went out in the Cortex A8, which was the first Cortex A-class processor that ARM made. And obviously, it was the start of a lot of the kind of smartphone revolution. So very exciting to be part of that. But it also got me to the offices of people like Nokia and Ericsson and some other companies, which generally we wouldn't talk about. And while I was over in Nokia and Ericsson, I discovered Wyberry. And for those that you haven't come across that technology, that's what became Bluetooth Low Energy and got incorporated into the Bluetooth standard. So that was my first sort of exposure to what became Bluetooth Low Energy technology. And then we got to announce this at a microprocessor technology forum. So I was in California for that one. The next project that I did was one called Embed. Some of you might have heard of this one, but it was at a time where ARM was deciding to do dedicated microcontrollers. So we started what the project was called Sandcat, and it became the first Cortex-M microcontroller. And what Embed was about was how, given that the world was 8-bit microcontrollers and no one believed that you needed more than that, how would you push the industry? How would you push it in lots of different dimensions? So we pushed it in terms of tooling, software abstraction, online collaboration, IoT, things like that. A really great experience, and this project grew and grew, and gave me the opportunity to work with a lot of different companies, IoT companies, and seeing the sorts of problems they worked on. So in that sense, we did a lot of work on Bluetooth Low Energy, but from a services point of view, it wasn't supported. Bluetooth Low Energy wasn't something we supported in services, yet customers kept asking for it. So really interesting project. Hopefully you all agree 32-bit microcontrollers have become a thing now. So amazing thing to work on. And as part of that, I was lucky enough to also write a pitch for the BBC on what became the microbit. And I was quite excited to get wireless designed into this. This was all sort of thinking next generation BBC Micro. But I wanted it to have wireless because, it was about IoT, and I think this is something really exciting for people to understand the potential. And this was a great project. I didn't take it on. Some of the people in my team, so Johnny, who's now CTO of Microbit, or Zach, who now runs Edge Impulse, they took it on. But I was very proud to get Bluetooth Low Energy in there. And I think it was partly due to the fact I gave, I think it was Thomas at Nordic a ring, and said, I've got this amazing project. I said the goal was to deliver 1 million of these to kids in the UK. Got this amazing project. Do you want to be on it? Yeah, okay. Can you give us the chips for free? And all respect to Nordic, they went away, and in not very many days they came back to us and said yes. So that was a very nice phone call that I got there. So amazing project. But what was really interesting for me about this one was I couldn't see any other way of getting wireless into wireless IoT into a product like this, because the margins was the cost requirements were so low. It was counting passives to get the cost of this down, because the goal was to give it away for free as part of the BBC program. So amazing project, but you can get the theme. A lot of Bluetooth going on. So today we're announcing a new company that I've been building with some really awesome people, which is called Blecon, and it's really focused on enabling IoT connectivity for Bluetooth Low Energy. So think classical, cellular style IoT connectivity using Bluetooth Low Energy, and that's what I'm going to talk about today. Hopefully it will be enjoyable. But it's obviously very exciting for us to be able to do this. The reason we did it at Hardware Pioneers actually is because we're building the company in the UK. We're actually building it in Cambridge initially. It's naturally going to be a global company thanks to Bluetooth's prevalence globally. But we're building it in the UK, and I was really excited to be able to first launch it here in the UK. Right. So why would you want to use Bluetooth Low Energy for IoT connectivity? So lots of companies are doing this internally. Lots of companies are trying to do this and struggling, and for very good reasons. Hopefully some of you are familiar with Bluetooth Low Energy and perhaps the distinction from Bluetooth Classic. But it's an amazing technology that's been sort of quietly developing in the background. So one of the main reasons people think of Bluetooth Low Energy is cost, right? The design of the silicon that you can implement a Bluetooth Low Energy peripheral device in is very, very small compared to other radio technologies, and that naturally translates to cost. But also things like the peripherals you have to put around it to, the antenna, the passives, they're really low, for a low-cost design. And then you also get into things like economies of scale. So these chips are shipped in the billions, thanks to personal devices. You can see how those economies of scale make it very attractive as a technology that people can build in. So cost is a really obvious one. A couple of other really obvious ones. Well, power. It's in the name. Bluetooth Low Energy has got some really interesting features and design trade-offs that make it very attractive for low power design. It can wake up quickly, it can advertise, it can go to sleep. So these are obvious ones, right? Size, as I said, the silicon area is very small. That means the actual dies can be very small, so the packages can be very small. You can integrate antennas into the packages. So there's not much that can beat it on size. So those are some of the obvious ones, and I think most people recognize Bluetooth Low Energy for those sorts of things. But when you start to dig into the actual technology, it's got a couple of unique features which make it really interesting, and we're actually exploiting. So the first is what most people will have heard as advertising, if you've come across that, or beaconing. So Bluetooth Low Energy can advertise its presence, and that's used for discovering a device and connecting to it, but it's also used in things like beacons, tracking beacons. That's actually what's being used in like an AirTag or like the original versions of things like AirTags. It's advertising its presence, something else is spotting it, and therefore you can locate this device. And they might be advertising 10 times a second. So if you got out your phone and checked now, there's probably hundreds of Bluetooth devices around you, all advertising their existence. And that's quite a unique property. You can put data in that advertising packet. But it's also what's used to trigger connections and discovery. And one of the things Bluetooth, I haven't listed all the things here, one of the things Bluetooth can do very efficiently is set up a connection. So it can set up a connection, perform transactions, and tear that connection down all within a second or something like that. So that's a really interesting property, again, that we've been able to exploit. And you can see how that impacts power. So one of the other things of Bluetooth Low Energy, actually the bandwidth is relatively high. It's not streaming video levels, but if you're comparing it to Sigfox or LoRa or something like that, you're talking tens of kilobytes a second rather than bytes a second, right? And that's the difference of being able to just transmit your current value to being able to store up values and send a whole data sync or download a firmware update and things like that. But because you can switch between these modes, you can work very fast, send a lot of data, but you can also just be advertising or just send a very small packet. You've got quite an interesting trade-off you can make in terms of power, right? Which is pretty unique to Bluetooth Low Energy. So yeah, you're not going to be streaming video and things like that, but actually the amount of bandwidth you can get out of these things makes for some quite interesting trade-offs. So another thing that it's got to its advantage, which I guess people take for granted, but is not true of a lot of technologies, is it is fundamentally global. So it's the same frequency everywhere. It's the same, it's recognized everywhere. That people understand how to sign it off in all different regions. So if you build a product, that single product can literally go to anywhere in the world and work, be signed off, be accredited by the local, wireless body or something like that. So that's quite unique. If you're thinking cellular or LoRa, that's that's not necessarily the case. So you might be managing multiple SKUs, thinking about, have I sent the right thing to the right person? Lots of supply chain considerations are there, but it's also a globally recognized brand. There's a lot of these things. I'm going to go through a few, but we've got a paper coming out that's talking about this. But one of the other things, and this is, I think, the real reason why companies clamor to try and use this technology somehow in a way it wasn't designed for, is it is ubiquitous. It's everywhere. So it is in every phone. It is in every laptop. Like, not many technologies can say that. It's a technology that, as I say, people understand all over the world. It's globally recognized. So it's not just technically, but commercially, and finally from that comes the ecosystem, right? So I suspect a bunch of you in this audience have built things with Bluetooth, and what that means is a technology like this actually is very accessible to build products out of. People understand what it is, they understand how to sign it off, and there's this massive ecosystem which gives you economies of scale, but it also gives you the ability to actually execute on projects. Okay, so anyway, there's loads of things I could have listed more, but this is why companies, despite Bluetooth Low Energy being classically a personal area network cable replacement technology, this is why companies are trying to use it where classically you would think of cellular or Wi-Fi or LoRa or something like that. Okay, it's very pragmatic. The technologist in you might not think this is the perfect solution, but the pragmatist, when you think pragmatically about all of these different technical and commercial realities, it actually it looks quite interesting. And I guess this is why also it doesn't get so much airtime, because it's just plodding along quietly, making all these things happen, getting better and better, versus new technologies that they capture the headlines because they have the potential of something else. This has been doing it for years and continues to get better and better. Okay, so that's wonderful. So why isn't everyone just out there using it? Well, the companies that have to overcome quite a few significant barriers, and that's obviously what we're interested in. How do we exploit all those benefits that you saw there by overcoming some of the barriers that get in the way of companies being able to exploit this technology? So I just wanted to highlight 3 key ones. So the first is kind of the fundamental architecture. So for people who are familiar, this is the classical connection architecture of a Bluetooth or a Bluetooth Low Energy device. And you can see why it's like this. This is how it's grown up. You have some sort of client, that's usually a phone or a laptop, and its goal is to connect to a peripheral, a keyboard, a mouse, a headset, a Fitbit or something like that. And that's what it does. And actually the device isn't a client, the device is a server. It's serving up information to the client, the laptop or the whatever, and it's asking questions of it. Dig, dig, dig. That's how it works. And then as they become more classically IoT products, what happens is this other loop starts to introduce itself, where that intermediary now has to, but then shovel that data up to the cloud, respond, get back. Okay. So you can already see there's some pretty obvious barriers here that you need to overcome. The device is acting as a server. Well, that's not really how most of the IoT connections work. The device is usually the client. It's the one waking up, sending a message and going back to sleep, or waking up, getting a request and going back to sleep. This client in the middle, this laptop, this phone, this old piece of hardware, a gateway, it actually has to be a custom device. So it has to become domain specific to do this transaction. So actually what you find is most companies are building a device and they find themselves becoming a gateway company, because they're fundamentally ending up building a bespoke gateway that is domain specific for their end application, right? And this just happens time and time again. It's very frustrating to see. And obviously sometimes, things like when you build a product or a company, it comes out of frustration. So you can only see this so many times and not get frustrated, especially as this is often the blocker. This is the thing they're blocked on. This is the reason they can't ship. But you also got this interesting security gap, because you've basically got 2 different security things going on here. You've got a client talking to a device over here, a server, and then talking over here. So you've got this gap, you've got this air gap, and that means you kind of have to either trust this thing or build yet another security protocol on top. And then we talked about advertising. So beacons, using the advertising feature of Bluetooth Low Energy are really interesting as well. They use a slightly different architecture. In this case, you could think of the device as the client. It is waking up. It's sending messages. And some custom gateway is shoveling it up to the server. But at least it's looking a bit more like a device. So this is actually, there's a reason why we call ourselves Blecon. This is looking more like what you'd expect, but it still has a different set of problems. So there's no response. So beacons, they're basically just shouting and hoping someone hears. Okay, but they have no idea if someone heard. So what do? Well, you just carry on shouting. You shout the same thing just in case, right? That's all you can do. You don't know anything else. And you're actually shouting constantly the same thing because that's all you can do, because you can't. There's no sense of motion and whatever. You can only send, this is the temperature right now or something like that. The data you can put in that advertising packet is very limited, and you are just repeating it. And there's no real security. I mean, you can solve this by actually having network layers that really understand what's going on here. But in general, if you thought of like Eddystone or iBeacon, stuff like that, they're not secure. They're just shouting in plain text, an identity, maybe a temperature, and that's about it. But it's an interesting technology. So, okay, so how do you solve this? Well, turns out we have solved it. I mean, you just have to look at something like Wi-Fi or cellular, and it's pretty obvious what the model is. So this is a standard communication architecture. This is what you would expect, and this is what most customers are trying to replicate. They're trying to make it look like an NB-IoT modem, but there's a lot lower power. Or they're trying to make it look like a Wi-Fi chipset, but without all the, getting onto a local network. So this is the standard communication architecture that people are really looking for. There's no surprises. The device is acting as a client. It's the thing that wakes up, says I have a question of the network or the service, or I have something to send. It works through a generic hotspot. I mean, if you had to install Facebook on your cell tower, or if you had to install applications on your Wi-Fi router to make something work, that would feel ridiculous, right? That's not how it works. This is network infrastructure. It's generic. And then you're talking to some server, and it's secure end-to-end. So you don't even have to trust the intermediary. You can't do man-in-the-middle attacks. You know it really is the device that's talking to you. You can attest, that is the device I heard last time, and it's the same device. No one's spoofing it, right? Pretty standard stuff. But just because of the heritage of Bluetooth, not what it is now. That's not how it grew up. It didn't grow up trying to solve this problem. It's just a lot of people are trying to use it to in this way. Okay, so let's have a look at one of the other barriers. And that's one more about how people actually deploy technology. So it's all very good having a technical solution, but if it's expensive to deploy, that gets in the way. That's actually a lot of reason why projects fail, because the technology is great, but the cost of deployment just doesn't make sense. So again, no surprises. This has been solved. So where did we look for inspiration here? Well, we looked at our friend Wi-Fi. And Wi-Fi has done something really interesting. Wi-Fi is almost a consumer technology. So consumers basically know how to deploy, something like a Wi-Fi access point, right? You plug in your backhaul, you plug in your power, and you have Wi-Fi. So we're not necessarily interested in consumer technology, but when it comes to deployments, the difference between you having to send out a skilled engineer to deploy a solution versus the customer, with a bit of nous being able to deploy it themselves, that might be the difference between a project working or not, or it might be the difference between you being the competitive solution and someone else not. So actually consumerizing technology, so it works in the way that consumers are used for, and solving the problems that they're trying to solve is a really interesting way to get costs down. Anyway, so although I've used a consumer router as an example here, it's not necessarily the point. The point is most people in companies are consumers. That's where they learn about stuff. And Wi-Fi's got some other interesting ones. Like, so if I took a phone, So I've got my cell working in here, but you need Wi-Fi. Okay, well, what do? Well, I turn on a hotspot, right? See, simple. There you are, and you can probably join it now. It's not actually my phone; it won't work. But I've just deployed Wi-Fi in my local area through a commodity technology. You'll notice things like, well, you need a password and stuff like that. We'll come to that in a second. But you can see the consumer model of deployment is really attractive to be able to deploy a technology and get the cost down of actually deploying it. Okay, so we'll take some inspiration from there. And then, well, what's the last barrier I'm going to talk about? Well, it's how you make a connection. Well, with Bluetooth, it's actually pretty obvious how you make a connection. You use pairing, right? You just pair a device. Well, we don't want to use pairing because that's a nightmare. Everyone knows about has Bluetooth pairing horror stories, but you actually need to change your product. You need a UX. You need screens. So if you're connecting this to a gateway, how do you type this in? Oh, web server or something like that. So pairing has a bunch of problems from a UX point of view that get in the way. They might impact the product you actually have to build because you have to have UI components to your product. But it has another property which, you wouldn't dream of in the cellular case, which is you're tying your device to a particular piece of equipment. You're tying it to a particular hotspot in our language, right? And in the personal area network case, it makes total sense. It's your Fitbit, it's your phone. It makes absolute sense. But if you're thinking of IoT connectivity, that makes no sense. So yeah, we're not going to use pairing. So what are we going to do? We're going to take inspiration from the cellular world. So how does cellular solve this problem? Well, they have a SIM card. And the SIM card, it represents a different trust relationship to, let's say, your Wi-Fi password or your Bluetooth pairing. Because what a SIM card is a SIM card is a trust between your device and the network, not the cell tower. All right? So the cell tower doesn't have to trust you indirectly. It's the network that has the trust relationship. So this is what really people are looking for when they're thinking of IoT connectivity. But it gives this other interesting property. Not only is the trust, it is more trusted. You really can attest that device. It's not like a Wi-Fi password that can get leaked and blah, blah, blah. But actually introduces this concept of roaming or mobility. So as a mobile phone operator, I don't have to pair my phone with every cell tower. I can just move around, and because of my SIM card and that trust and the network managing that trust relationship, I can move around. And that's actually a really exciting property. So what we really want is all these benefits of Bluetooth, so like the low power, the low cost, some of the technical features we want to do it, use. But we kind of want the cellular, the Wi-Fi model of deployment, so how easy it is to deploy hardware, get coverage deployed in a local area. But we want this cellular model where a device can phone home wherever it turns up in the world. Okay, so Bluetooth, Wi-Fi, cellular. Are you getting it now? Sorry, it made me laugh. So this is what we've been working on. What we've been building is all the benefits of Bluetooth, the deployment model of Wi-Fi, and this network model of cellular. And if you hadn't guessed it, we're going to call it Blecon. So that's the name of the technology. And basically, Blecon is bringing IoT connectivity to Bluetooth Low Energy. That's our goal. So we love Bluetooth Low Energy. We know lots of companies are trying to use it in this use case. We want to help them today. But also, I think we also know there's a lot of potential that people don't even realize with Bluetooth Low Energy and how low those chipsets are going to go in terms of cost. If people have seen like printed Bluetooth Low Energy labels and things like that. So this is what we're dedicated to. We're building effectively networking for Bluetooth Low Energy. So let's quickly go through this. So first up, we have the network. This is a service that we've built. And, in some sense, no surprises. It's a network service that you can plug into your cloud backend. So it's not an IoT data platform or anything like that. It's fundamentally a network. You plug it in to your cloud backend. It can manage all the hotspots in your deployment. And then devices can talk to that network. And by building it like this, you have this opportunity to have device mobility. A device can move around at any point in time. It can use a different hotspot. And that leads to some really interesting flexibility in how you can deploy the technology in a device. We also have hotspots. What's the time? There's no timer on here, just out of interest. Okay, cool. All right. So we built this Blecon hub, which is a hotspot. If we have a look in there, it's basically Ethernet, Wi-Fi, and cellular backhaul. You just plug it in and it will work anywhere in the world, and it's powered by USB and power over Ethernet. So that makes it very simple to deploy coverage somewhere. But of course, there is one more thing. So we actually, because of the deployment of Bluetooth, we can make an app. So we've made an app for Apple, iPhone, Mac OS, Android, Windows, and that allows this to be a hotspot. A phone walking around a hotel in a cleaner's pocket. A laptop in an office can be a hotspot. A point of sale terminal can be a hotspot. The GPS in your taxi driver or your delivery driver's setup, or the scanner in your warehouse. All of these are basically hotspots ready to be enabled. So this is really exciting because you have physical and virtual ways of deploying coverage. But also, the hotspots can move around. So it's not just the devices that can move, the hotspots can actually move around. So that now you start to get some really interesting models where the hotspots move to give effective coverage. And then the last thing, we're going to do integration. Yeah, how much time is it meant to be?
Yes, you've got 2 minutes.
Oh, okay, all right, cool. Yeah, so we were going to do a demo. I think we'll do a demo at the stand. With the heritage we have from things like Embed, we understand what it takes to integrate this. And it's basically two different teams, right? You have an embedded team, you have a cloud team. They generally speak different languages. So we spent a lot of the product focusing on this. So on the hardware side, we have a firmware modem that you can just drop onto any Nordic chip, and that treats it as a modem, or a library that you can drop onto any Nordic compatible chip. And for the network, well, you just pipe it into your cloud setup, so your API gateway or your Lambda or whatever, and the data is flowing into your cloud for you to treat however you want. So I was going to do a demo, but I think we'll do a demo at our stand over there. Sorry, Don. Don's been waiting patiently to do a demo, but there it is. You almost got it. So what we've built is effectively a Bluetooth Low Energy IoT connectivity with very flexible hotspots and no pairing. Leveraging sort of what you take for granted for Wi-Fi and what you take for granted for cellular. From today, you can sign up and try it out. The documentation's online. You can go and set up your own network and get the access to the firmware, so you can get started and have a go. You can talk to us as well. So we're on the booth just behind Nordic over there. Or if it's after the show, go to the website and you can chat to us online or set up a meeting. And we'd be very happy to talk through if it works for your project. We're going to be at Embedded World in Austin for anyone who likes barbecue. That's where we're going to do our US launch. So please join us there. Thanks very much for your time for listening. It's very exciting to be able to launch this. And hope to hear from any of you at our stand over there if you want to ask any questions or get more deeply involved.
Thank you so much, Simon.